Hey everyone, it's Mr. Canfield. Today we're going to look at doing definition of the derivative. So we started out last class and we worked on it, but I'm just going to kind of refresh. There's a formula that we use for definition of the derivative. And if you apply that formula, you have what we call the derivative. And we talked about where it comes from. I do recommend, if you're not sure about like how it works or you're interested, definitely look something up online. There's some cool videos that show why the definition of the derivative is what it is. In short, instead of finding the slope between 2 points, the definition of the derivative helps us find the slope at a single point. So up here on our page, we have two different forms that we write it. And we learned yesterday in class that the H actually used to be an I, and I stands for infinitesimal, which is like this little tiny thing. And then along the way, they changed it to H, and I can't quite remember the reason why they switched it to H, but it's just a couple hundred years old that we do that. But anyway, so if I want to find the derivative of this function, all I need to do is use the formula f of x plus 8. There is no way I'm going to fit this in this space. Let's blow this up. So let's see, we got x squared minus 3x plus 1 f of x is equal to, okay, so right off the bat, we need to we use the formula, the limit as h goes to 0, definition of the derivative always is the limit as h approaches 0, of f of x plus h minus f of x all over h. So if we do this, okay, f of x plus h, what's the idea here? The idea is that we're taking x squared minus 3x plus 1, and anywhere we see an x, we're getting rid of it. So we got parentheses squared minus 3 parentheses plus 1. Then it says minus f of x. Oh wait, we should probably plug this in. This goes in the place of the parentheses, x plus h. Then it says minus plain old f of x. And making sure to put parentheses around that, otherwise we're going to lose negatives. Then we got our h here, our limit's still there. And then we just do blah. Now I want to see, can I plug in 0 at the start? And if you were to try, you'd wind up getting 0 over 0. Take my word for it. If you really feel like it though, plug it in, you'll get 0 over 0. So let's see, if I want to FOIL out x plus h squared, remember this is saying x plus h times x plus h, so I need to be careful when I FOIL that. Now those are like terms. So we're going to say I've got the limit as h goes to 0 of x squared plus 2xh plus h squared. Distribute this negative 3. We get negative 3x minus 3h plus 1 minus x squared plus 3x minus 1 all over. All right. So I'm looking for like terms. So I got x squareds. Sorry, what I'm doing right now is if I were to plug in 0 for h, this still doesn't work. So I'm canceling it, and I want to see if there's anything I can do after that. So it's not a coincidence that everything that didn't have an h canceled out. If it's a polynomial, this always happens. So we look here, we still can't plug in 0 because we get 0 over 0, but if you notice in the numerator they all have an h, so we could take an h out of all of them and get 2x plus h minus 3 all over h. Now we can cancel them. And now I can take the limit. I can plug in 0 for h and get 2x plus 0 minus 3, or just 2x plus, minus. I dropped my pencil. So far away. Okay. -3. Okay. So remember, we stopped writing the limit notation as soon as we plugged in our number. And then remember that since we started with f of x, we could call this f prime of x. And yes, this was a 1, 2, 3, 4, 5, 6 step problem. We're going to learn very shortly how to do these in our head, but I didn't tell you that. We're going to learn shortcuts. So we can say f prime of x is equal to 2x minus 3. It says find f prime of 2. That little let's try again. That literally means f prime of 2, which just says, hey, take anywhere you see an x, rip it out, plug a 2 in place. So f prime of 2 is 1. And I can do it again. F prime of 0 is equal to 2 times 0 minus 3, which is -3. And f prime of 1, or -1, is 2 times -1 minus 3, which is -5. So once we have the function of the derivative, like, oh, I know it's 2x minus 3. Once we have that equation, we just plug in x values and find out what the slope is. Oh, spoiler alert. Derivative and slope are like the same thing. So let's use that idea on this next question. It says f of x is equal to 4x. That's a line with slope 4. So if I do the definition of the derivative, I wonder if I'm going to wind up with a slope of 4 regardless of what the x value is. So number 2 says f of x is equal to 4x. So then if I look at the limit as h, I make that mistake all the time, as h approaches 0 of, now I'm doing f of x plus h. So that means anywhere I see this, I do rip out the x and put in x plus h. And then I take away f of x, I put that all over h. And some of you might even see where this is going already. So the limit as h approaches 0, we get 4x plus 4h. The minus 4x is still there. Well, hey, would you look at that? The 4x's cancel. Now we've just got the limit as h goes to 0. 4h over h. The h's cancel. It equals 4. The limit as h goes to 0, 4. Plug in 0. It's still 4. The limit's 4. Because the slope of this is 4 no matter what the x value is. On to example 3. I promise I'm not farting. My chair just makes these noises. So this one says g of x is equal to x squared plus x. So if we apply the definition of the derivative, then we'll say g of x plus h at the beginning. So that's, we're going to be plugging in x plus h in its place, minus f of x, so x squared plus x. And I do recommend that parentheses so that we don't lose the parentheses and lose the negative, all over h, and then limit as h goes to 0 needs to be out front. And now we just need to walk through and do the steps. So this first one will get similar to something we did earlier, or the exact same thing as what we did earlier, x squared plus 2xh plus h squared. For me, that's a memorized formula. I don't even bother foiling it by hand. I know that if two things are added together, you get their squares on either side and double their product in the middle if the whole thing is squared. It's related to something called the binomial theorem. Distribute the negative. We've got the h. And so, like how it happened before, I'm expecting anything that didn't have an h to cancel out. So like here, the x squareds cancel, and the x's cancel. We're left with 2xh plus h squared plus h all over h. I'm going to pull an h out and get 2x plus a single h plus a 1 all over h. Remember though, I haven't taken the limit yet. And now when I plug in 0 for h, I get 2x plus 1. That'll be g prime of x. So there is a pattern to this. So if you think you're picking up on a pattern, that's awesome. All right, let's see. 2x squared minus 5x plus 6. That is our f of x. So this one's going to be a little bit annoying, but that's okay. So I'm going to give myself a little bit more room. Start over here this time and say 2 parentheses squared minus 5 parentheses plus 6. Like remember, I'm taking these out and I'm just going to put x plus h where the x used to be. Then minus that. All over h. Whew, okay. So if we're going to FOIL this, we got to be careful. There's the 2 out front as well. So it's still going to be x squared plus 2xh plus h squared, but then there's a 2 to distribute. So 2x squared plus 4xh plus 2h squared. I'm just going to cross that out and leave that above it. Distribute that minus 5, minus 5x, minus 5h plus 6. Distribute the negative, minus 4x squared plus 10x minus 6. Ooh-wee. My eyes are glazing over just a little bit looking at this, but it's okay. I see the negative 6, I say plus 6, canceling. What was I doing? Why did I multiply these by 2? Oh, because that 2 earlier. Silly me. That should just be minus 2x, right? 2x squared plus 5x. Whew. All right. A little too much autopilot. Flew into a cliff. All right. Minus 2x squared, got a positive 2x squared. They're going to cancel. So just be careful not to lose things like the minus 5h. We got a 2h squared. We got a 4xh all over h. Thought I was going to need more room. Okay, yep, didn't need more room. So I can pull an h out of the numerator and get 4x plus 2h minus 5 all over h. The h's cancel. Plug in the 0 for h, that turns that whole thing into 0. We get 4x minus 5. Cool. That would be our f prime of x for number 4. Number 5 looks like fun. Let's see, 5 says 4 over x So let's find dy dx. Remember, dy dx is the same as like finding f prime. So we could say dy dx is equal to the limit as h goes to 0, f of x plus h. That's weird on this one. 4 over x plus h minus 4 over x all over h. So you might look at this and go, wow, that's terrible. That's fair. But I could combine these two fractions in the numerator, right? I could go and say, well, this one's missing an x over x. And this one's missing an x plus h. X plus h. So just to clarify, I can't say this one's just, no wait, I can't say this one's just missing an h and that they are the same. Remember that common denominators need to be multiplied together. So like if we had 2 over 7 and 3 over 10, we were trying to add those together, the common denominator is not 10. Like I can't just add 3 to the top and bottom of that. I had to like take them, I had to multiply that by 10, I had to multiply that by 7 and get a common denominator of 70. That's the same principle here. It's not something where we can just add something on if we want to. They're completely different numbers. So if I do that, I get 4x minus 4 times x plus h all over x times x plus h. And we can't cancel anything because of that minus sign here. It's connecting things in ways we don't want. That's all over h. And you might think, wow, that's just so awful. Sure, that's fine. But just bear with it. So we have 4x minus 4x minus 4h all over x times x plus h. I'm not convinced I need to do anything with that. That's why I'm leaving it. And then what if I tried plugging in 0 for h right now? Well, up here, the 4x's are going to cancel, and we're going to have 0 on top of non-zero, and then that's going to be 0. So we have a little bit of a problem right now. But if I think about this as negative 4h over x times x plus h over h. Okay, that's annoying to think about it that way. But instead, what if you thought about it as the top divided by the bottom? Another way to put that is the top multiplied by the reciprocal of the bottom. And now we simply have negative 4h over x times h times x plus h. Cancel the h's. We have negative 4 over x times x plus h. Forgot what the limit thing is. Ooh, I'm putting x's. Put h's there. H. 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 Okay. Now when I drop in 0, I get negative 4 over x times x plus 0, or negative 4 over x squared. That is my y prime, or my dy dx. That problem is, yeah. It's okay. We're going to learn a shortcut for this too. It actually follows the exact same shortcut that examples 1 through 4 all followed. But yeah, beyond that, we've got 7 problems to try in the homework, and Should have already done 2 for next class, but I hope stuff's going well, and I hope this was helpful. Bye.